I'm not even sure what the format will be, but I think there's going to be a lot of Q&A because I probably care more about what you care about, and I'll give you answers to that. People always ask me, what am I working on now? The hint is, it's not Kubernetes, surprise. But I spend most of my time these days figuring out how to deal with the problems Kubernetes caused, which is how do you manage all of these configs? How do you communicate to people the best workflow for making these changes? So we definitely have a much better API, I believe, for managing apps across compute, but it also presents some new challenges that I think people have never had to deal with before. And so my time these days is spent a lot in the serverless realm, even when it comes to things like Kubernetes. So at GCP, we have Kubernetes Autopilot. So I'm super interested in all the things you do above the infrastructure layer. And also the other thing that's pressing is multiple clusters across multiple regions. A lot of our customers now have gotten hang of this Kubernetes thing. They're getting a ton of value out of it. And now they want to do more ambitious things like, can we get this compute, including our databases, to run across multiple regions? So that's the areas that kind of occupy my time. That's the stuff that comes next. And so, yeah, that's it's where I spend most of my time, is where a lot of my curiosity is. And we're going to use the rest of the time for Q&A. So this session will be as good as your questions, I hope. So if you ask a question, I'll give you a very elaborate answer and try to give you all the details about how I think about these things. And pretty sure there'll be a lot of my own personal opinions in there, but I think that makes it slightly better. So if there's any questions, we can either drop them in the chat here. I'm not sure if there's a mic set up there, but either way, let's just drill a round of Q&A and see where we go.
I thought you would be giving a talk on Kubernetes, really, Kelsey.
There's plenty of talks of me talking about Kubernetes on YouTube. So if anybody want to watch me,
I saw them on YouTube. I actually saw them on YouTube. So my question would be, if you experience a setup with a company who tries to change its software into something new and modern, throughout their project, they discover that they still have to care for quite a lot of old batch processing things. And how would you go about these kind of batchy things that are somewhere hidden in the depth of the legacy system?
Yeah, so before I started doing all this open source work and working at companies like Puppet Labs, CoreOS, and now Google, I used to work in like normal enterprises, like even financial services for like 3 years. And what their legacy was like mainframe, right? So they're coming from a world where most of the stuff was written in COBOL. They were trying to adopt Java, but the truth is most of those systems never go away completely. So I think the thing that I've learned in the last 20 years, number one, we probably shouldn't call it legacy anymore. It's not legacy. It's like the thing that pays the bills. Most of the new stuff hasn't achieved, like, if you play like soccer or something and you score lots of goals and you win lots of medals, we don't look at those as legacy players to be replaced. We look at them as players who've done a good job that should be celebrated. And I think of software the same way. I think it really comes down to this like maintenance problem. So in that financial services situation, we have all this COBOL stuff, and it was good at the time. It was probably the best decision at the time when they chose to adopt that computing or, data processing paradigm. So when I started there, probably, 2008, 2009, lots of people would be complaining about the COBOL and how it sucks and they should throw it away, but they didn't have a replacement. Everyone was like, we're just going to rewrite everything in Java, but they didn't understand what this thing was doing in its current environment. It turns out mainframes are very fast. The team taught me about packed decimal, if you don't know what that is, and EBCDIC. These formats and ways of representing numbers and half the bytes, this stuff is really, really, really performant. And when you're a company doing hundreds of thousands of transactions and maybe millions sometimes, you can't waste a single byte. It gets that specific. And so for me, my approach was to respect the current system and ask myself, why is it here? So I learned COBOL. I learned COBOL enough to write Python libraries to allow us to continue to process EBCDIC files, to continue to do number representations in nibbles and packed decimal. And I learned that you could actually take these data formats, no matter what language you use, and actually move them across those existing systems. And it gave us optionality. And so for me, as a pragmatist, I always try to understand the current system and how much value it actually brings to the business. And then I try to do something in a way that's pragmatic, that represents a checkpoint in a long timeline, right? Whatever you currently have is v.1, and your goal is to get to v.2, but you got to show value along the way. So whether it's microservices, a monolith, cloud native or data center native. Like to me, these are all buzzwords. So I like to peel back the fundamentals. I like to inspire people through results. So I'm not a big fan of big transformations. So whenever I hear digital transform or modernization, I've never seen it. Mainly because you can't really modernize anything. It's probably going to still be HTTP. It's still going to be a string of bytes on a file system that's being moved around networks that were designed 20, 30 years ago. And so instead of thinking of it that way, I would ask the maintenance problem. Why have we stopped maintaining the current system? Why have we not thought about updating the current version of the runtime we already write code in? That behavior will eventually leak into the new thing, right? Everyone likes to do the new thing, but if the behavior around maintenance and that professional part of what we do is not there, then the new stuff will look worse than legacy because you're not thinking about all the bugs and outages that it takes to create stable software. And so that's my approach to this modernization effort. Pragmatism, think about things on a timeline. What you have is valuable. It deserves a better name than legacy. And then what are the incremental checkpoints that actually show value? Because you're going to be maintaining 2 to 3 systems in parallel as you attempt to replace, if you ever do it. And so that's my kind of views of thinking about managing and thinking about modernizing software, maintaining it.
That's a great answer. So I like the part about respect for old stuff. You kind of hinted that it might be a good idea to understand better what, let's call them the older systems did, and maybe reuse some of that stuff. I kind of hope that you would say we have a special branch in Kubernetes that deals now with host and COBOL and or BS2000 or whatever. You didn't say that, right? Or do you have a...
Well, here's a funny thing. I did a keynote for a company called Synergex, and they build a lot of these reservation systems that have been here since the 90s. And this stuff is, I mean, green screen. So if you go to a hotel, and many airlines today still use these green screen based reservation systems. And so they asked me to come speak at their conference, and we did a few engineering sessions with their team, because what they want to do is get people to be able to run outside of these very old hardware that they don't even make anymore. And they decided to do the engineering work underneath to do some emulation and also to port things to Linux system calls. So what that gave them though was same software, same green screen, same protocols, but now they just work on a different kernel. And so once they got the Linux compatibility, we were able to take that collection of bytes, the deployment artifact, throw it in a container image, AKA a tarball, and describe to Kubernetes how to place that tarball on very similar servers that they were using when they decided to adopt virtualization. And so what I did was just say, look, the fundamentals of Kubernetes are roughly the same fundamentals of virtualization, except we have a different config language on top to help us with placement, config management, and so forth. And so they were looking for a magic system, but the truth is they didn't need one. They just needed to make sure that the app was compatible with that environment, and then it opened the door to using a new system to manage it with the same fundamentals. So when I talk about Kubernetes to most of these customers, it's more of the thing you were already doing behind an industry standard API that happens to be extendable, and there is no magic here. If you look under the covers, it looks very familiar to what you had before, but that's the beauty of the system. It's pragmatic.
All right, so let's take a look in the audience, and there's Christian having a question.
We are currently trying to build a lot of microservices and trying to replace an older system. And our current plan is we want to get rid of the older system entirely. Now you mentioned not sure if that's ever going to happen. You've seen it in many places. They try. It's difficult. How do we manage the scaling down of the big monolith that's taking a lot of capacity to do that? It's quite expensive to run. How do we approach that?
Yeah, so I think the way I think about it is like you as a human. I'm 41 years old. My cells have been replaced through the normal process that the body goes through, but my heart, my brain, my eyes, some things are roughly the same. The interfaces are roughly the same, but I'm definitely not the same person I was yesterday. There's been very small changes inside. There's very clear contracts, right? The way I breathe, the way I hear, the way I talk. Those things are consistent. And I'm pretty sure we got microscopic levels the inflections in my voice are slightly different than they was when I was 35 years old. So the interfaces, when you think about your existing system, why were they even built, right? If I was a bank, I have a payment system that can take in payment information and settle transactions. You still need that behavior. And so the current system represents an implementation of that behavior. More than likely, the new system will represent the same behavior. Now, you can change the API, you can make it faster, you can get to some latency boundary. So how would I think about, so before I even start trying to redo a system, and I've done this 3 times in my career, and I never claimed that the other system got sunsetted, even if none of the old code exists, mainly because there are usually other consumers outside of one organization that have to consume your APIs. And so when I think about these systems, I ask myself, the current behavior, how is it expressed? Can I see the API? How do I call and get this behavior to work? And so that's V1 of your API. And so let's say you were rebuilding this bank. I got payments API, I got accounts API, I got promotions, I got email, I got security, I got all these APIs because they represent the behavior that a bank needs. The team wants to build a new system. I'm asking, why are you building a new system? You could tell me the old one is built in a language we don't like anymore, or we can't find anyone to hire. Okay? So you mean to tell me the API will stay the same, the behavior will stay the same, the latency will stay the same, and the bugs will stay the same? Because at some point, bugs become features. You remove a bug, you will find out how many people were relying on that bug and that behavior. So this is what you're telling me, that you want to use a new system because you want to have a more maintainable programming language. And I might say fair game. So now, can you tell me everything that the old system does? You will say, no, that's the problem. It went unmaintained. You don't understand the behavior. So now you're going to go create new behavior that's going to have to get tested all over again. And you're going to have to try to figure out a way, does the new behavior match the old behavior? And more than likely, you're not going to be able to express this. Your customers will. They'll say, hey, we're using the new API, and we noticed something weird. When we run our reports, you used to give me this in decimal format. Now it's an integer, and it's all broken. We were really relying on the decimal type and not the integer type, and now everything is broken. And in your mind, it's like, why would that be a big problem? And it turns out it may be. So first step is the behavior of the system. Now let's talk about evolution over time. Modernization could be, we need to support Apple Pay. I'm a bank. Apple Pay didn't exist when we built the first system. And so now we get a chance to build and integrate with the quote unquote modern world, right? Apple Pay is different, but it's fundamentally the same. There will be a terminal, payments will happen, and we have to settle the transaction. That's fundamentally the same. So from a behavior standpoint, I already know most of the system I have in place can be used, except for the part where I have to integrate with the protocol. So now I'm going to go think about, how should I do this? Well, the team has expressed a desire that we want to use a new language that has a better hiring capacity and opens the door to more tools. Fair enough. So we decide we're going to do the Apple Pay integration using this new language. But as a responsible engineer, I want to know that I can reuse as much of the behavior from the old system and just build that clean adapter for Apple Pay integration. And you know what? I got to do Google Pay, PayPal, Stripe. There's a lot of these. So that new system may represent a bridge. And I think a lot of these new modern systems end up bridging to the new world. So now the existing system is 1.0. 1.1 is going to be 1.0 plus this bridge. And then one day, maybe the volume starts to increase so much that the current payment system can no longer keep up. Now we have another reason outside of behavior and API to actually work on the payments backend, because we didn't have one before. We just needed a bridge for the protocol. That didn't require a whole rewrite. But if you can give me a performance issue, which is a great problem, we can no longer handle the 10x number of transactions we are getting. That causes that maybe not the API is changing, but the behavior of the system needs to change. So now we're going to give the team permission that in 1.3 or 2.0 of the payment system, it will match performance. The reason why I'm explaining it this way is because I think when you're building a new system, you need to know when to stop. That's the biggest challenge I've seen. Engineers don't know when to stop. If I told you all you have to do is build a system that can handle 10 times more transactions than before, that doesn't necessarily mean you got to change the API. It doesn't mean we need to move the GraphQL. It might mean you just need a different database technology, or I've seen this, go from spinning disks to SSDs, put more memory and configure the database to keep more on the hot path than the cold path. Boom, 10x as an engineer, stop. That's what I mean by pragmatism. And this is why I'm saying that the old system really never goes away. It just evolves, maybe evolves so much where it doesn't look like the old system anymore. But trust me, it's still there in essence.
So what you described was exactly the approach that we did at my previous employer, worked perfectly. Here we're already in the middle of like replacing a monolith, and it kind of makes sense to go through with it, right? So my question was more about like, how can we already replace a lot of functionality? Now we have it double in the monolith and in a separate system, right? How would you approach scaling down the monolith in order to be more efficient?
Well, to me, and actually I saw a lot of engineering blog posts in the last 3 to 4 years about companies going backwards. Like the companies we respect, the Twitters, the Stripes of the world, they went too far with this microservice thing, because microservices, you know the trade-off. I'm assuming y'all are experienced engineers, so I'm not telling you anything new. Creating those latency boundaries from in-process, in-memory processing to across the wire with TLS encryption and additional kernel hops, this ain't free. So what most people find out they end up building is a system that went from 30 total millisecond latency end to end to 500. And then other things start to become a problem. And so it is not too late to reverse course if necessary. I'm not telling you have to do that, but that is the classic mistake to believe that you just have to do this no matter what. The system should be feedback on itself. So to me, when I think about this kind of design, so you have the monolith, and I've done this pattern, I think it's called the Strangler pattern. There's lots of names for it. I have a monolith. I need the team to tell me what's the first subsystem that we're breaking out. And it should be very obvious why we're doing it. Hey, we're doing user management first because we want to use different user management techniques around security. We want to go to jot token, something great. That's the great first one. Finish it 100% before you touch the other one. We're not doing them all. We're going to do one. And if you take the user management service, I got a monolith and I got a user management service. First thing we're going to do is refactor it to be a modular library so it can be deployed via the monolith, because that's the one that works today. And then we're going to allow it to be embedded in a standalone binary with its own API. So now in the monolith, I want a feature flag. The flag says, use the one that's in memory or use the one that's over the network. And I can turn it on and I can turn it off. And what I want to see is a couple of deployments where you've upgraded a few times, monolith, user service. Then I want to see the feature flag say, use the network one. And I might use the network one and I might use the in-memory one, and I better get the same results, because why not? It's the same logic. One is just over the network, one is in process, and they're still talking to the same database. And that's fine because they're modular things. So if you have this pattern, you've finished your security stuff, you finished observability, you have your logging, you can deal with all the complexities that come with managing multiple things. You now have CI/CD pipelines, you have education, you have training. Now you have confidence. So now the team says, all right, Kelsey, we love this pattern. It worked great for the user interface. And now we are removing the code from the monolith, and we're going to have a party to celebrate that there's no longer a flag. The only thing now is a configuration that says where to call the user service. Good job, team. Now let's have a plan. What's the next one? And you got to tell me why. Don't just tell me it's because we're doing microservices now, because I would still say I would refactor it into the modular module and embed it. But if you can't give me a good reason why it needs to run over the network, I might say, look, we could do it. We have the ability to do it, but we're not doing it because of latency problems. So we're going to choose to run this service in process until we get another reason why it needs to be. So I do like the modularity approach, clean up your code, tighten up the contracts, tighten up the interface, even in process, and give the team optionality to go dedicated binary or not. But that would be my engineering philosophy. And then when it makes sense, you can do it, because if you go read those blog posts from the last 4 years from everyone that was microservice, 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 and then watching them say, yeah, I don't know if we really needed 8,000. We've now cut back to 300. And the only reason they can cut back is because the code was modular and they were just able to import it as a library, add the handler, and then you solve some of your latency and security problems if you have them. So that's just my philosophy around modularity. And that's very different than microservice versus monolith deployables.
So hi, Kelsey, I'm Tim. I think 4 or 5 years ago, you tweeted about everybody wants PaaS, they just want to build it themselves. I'm paraphrasing here, I don't know the exact words. And now I'm sitting here and you basically gave me my team, like a platform team. So where do you think this whole space is heading? Because there's internal developer platforms.org, like community-driven thing, where people write about their ideas of the products. And there's a lot of talk about when is Google going to do their own internal developer platform, where you like abstract all the way and developers don't have to think about all that overhead anymore. When is Microsoft going to come, or is there going to be like a new startup that's going to take over? So I was just wondering, what do you think about that? Because that's kind of, for me, the logical evolution after Kubernetes.
Yeah, so it's funny, in 2008, maybe 2007, Google did that. We called it App Engine, under the same belief, like, what are you doing? You don't need all of this. What you need is a simple application framework, and it's going to have a memory store for caching. It's going to have a really nice database. And we didn't have Spanner at the time, but you can imagine us just saying, use Spanner, use Bigtable, use BigQuery. That should take care of most of your data needs. Use GCS for Object Store. Use App Engine, you get load balancer, you get DDoS protection. That's it, end of story. And the world was like, nah, that ain't gonna work, because we're still experimenting with stuff. There are some people who are doing like real-time streaming that need to modify the kernel. I think the type of apps people are building these days are so complex that the best we can do with serverless like Cloud Run and App Engine, we can give you a very opinionated thing. That means you need to conform to the opinion and kind of move with us lockstep. I think the challenge with that approach, though, what we saw was when Docker came out, Docker mitigated a lot of those conveniences, because Docker said there's an easier way to package an app and distribute it. That was one of the nice things about Cloud Foundry, Heroku, and App Engines, that you gave it source code and you said push, and it dealt with the complexities of a build and packaging and runtime. But I would argue that Docker did a lot of that now, that you can do this for even Haskell. So instead of having a limited set of golden languages like App Engine did, where Java, Python, we didn't even support Go at that time. And so I think you started to run into a situation where developers are always evolving, their tools are evolving, and most of those opinionated platforms don't keep up, not equally for all programming languages. So I think there's some abstractions that are a little too high and opinionated, and it all comes down to who should create them. So the analogy I like to think about now is grocery store versus restaurants. I can find a really good restaurant that has the right menu. I think it's going to be good for me because I don't know how to make Italian food, for example. But do I want to eat that every day? Then it becomes a problem. One restaurant is not going to be able to serve all my dietary needs. And so you're going to get in a situation like companies are doing machine learning now. Is App Engine going to do machine learning? No. And so now we need a machine learning platform. We need a big data platform. We need things to do big batch workloads. So I think where we're at now is workloads will dominate and workflows. So we have a batch service that is really optimized for big files, dynamic compute, spin it down, maybe add a DAG so that you can do some workflow and retry logic, but that's a batch workflow API. Cloud Run is a service workflow API. Cloud Functions is a function workload API. And I can go on and on. So what I think we're going to find out is that giving platforms like Kubernetes, you're going to be able to view it under any workload API that you want. So if you want to do machine learning pipelines, great. There may be a thing that adds that. Argo CD adds a CD workflow on top of Kube. So once we start to decouple the execution engine, scheduler, and all of these things, config management from the workload API, that's when we start to get into these developer portals like Backstage from Spotify, right? So I've met with the Spotify team many times. I was just in Stockholm not too long ago. And the Spotify team really is ambitious about Backstage. But here's the problem with Backstage. It works great for Spotify. And if you want it to work great for you, you're probably going to have to extend it and change it and do some weird things because your engineering culture, the way you think about solving problems, your starting point is very different. And so I don't know if everyone's going to be able to shoe into Backstage. But the thing I am hopeful of is that Backstage as a framework that says we're going to give you the 80% of things that you need anyway, but we're going to make it pluggable even at the UI layer. So you can do what? You can have the workflow that works best for your engineering organization. That is where I think we're going to end up with. And then guess what? The more of these workflows and developer portals that people create, it's just going to hide Lambda, Cloud Run, Kubernetes, and regulate them to just infrastructure execution frameworks while the workflow sits at the very top.
Hi, Casey, Philip here. I was wondering, earlier this year, you talked on the DevOps convention about the future of Kubernetes and talking about silos not necessarily being something bad as long as you have like contracts, like APIs and stuff like this. And you also talked about that you do not want your developers to kind of have to play with things like a kubectl and stuff like this. And I think this is kind of going in the direction of the topic Tim just mentioned. But out of your experience, what are kind of the topics or the points in working with Kubernetes that would be most effective if we abstract it for the developers?
Yeah, so I'm going to try to do this over time because I think that's the most honest way to do it. On day one, you haven't made a lot of decisions yet. You haven't decided whether you want to use Helm or Customize or Rancher or whatever. So it's new. And so everything's looking at this thing. Everyone has the same starting point. If you're, and the reason why I like the specialization area is because someone does need to have internet access. I'm pretty sure you all are not ISPs and do all of this yourself. So you go get internet access and you get power access and then you get servers or virtual machines or whatever you're doing. And then so once you have that, you install this layer, this contract on top that says, we're not going to talk about power. We're not going to talk about BGP routes across the world. It's just routable internet. We just take that as an assumption because the contract is so strong. So we bring in Kubernetes as our first contract layer. So what does that mean? We stop talking about very low-level machine things over time. So day one, you have Kubernetes installed. As the platform team, on day one, your job is to make sure that everything below that Kubernetes API is solved. Scaling, node count, region, zones, IAM, whatever it takes so that the apps that run against that contract work. So that's your specialization. Give me a set of Kubernetes APIs in the right places I want to compute and just keep them available for me and give me capacity. Great. If you do that well, then you create this illusion. So a really powerful one too, that here is the Kubernetes surface. And so this day one, I'm on the development side. Remember, we haven't made any decisions yet. So the only way I can interact with this contract is via kubectl. So I craft my own manifest. Maybe I store them in a Git repository. And when I want to deploy them, I call kubectl on my laptop. Now, we don't want people deploying from their laptop, but you understand where I'm going. If we like that pattern, what most people evolve to is taking that kubectl apply semantic and put it in their build pipeline. Because what you realize is Kubernetes is a last mile technology. And so your build process is roughly the same. The way you execute unit tests is roughly the same. The only thing really changing here is the fact that I'm going to package it in a container image because then it can be used in those manifests that I wrote to call kubectl apply. Great. Now we're going to go from our laptop to the last stage of our existing build pipeline. So that's day two. We now have some patterns for creating manifests to deploy apps, and we call them from the build pipeline. Easy enough, but then frustration sets in. Every developer is writing Kubernetes manifests, and it's just nasty because they don't know how to manage variables between the environments. This team seems to be creating the same manifest as this team is with a slight nuance. And you're just like, man, we need standards. There is no way we're going to teach all of these developers everything about pod disruption budgets, ingress services. And in many cases, you don't want them to, because some of that stuff is just a little bit out of scope of what they need to be doing. So you ask yourself, how do we create some tools, templates, if you will, to make this easier? And now you get that second decision of, do we go with Helm charts? Do we go with customize? Do we do GitOps, right? Workflow. Because what we want to do is be able to have a way to say, describe what you want. And for a lot of people, the Kubernetes API, as rough and rigid as it is, it's an okay day two semantic. And maybe you just go straight into GitOps, where you just check in stuff. Maybe you export things to variables using customize, but then you go into this pull model where the clusters are pulling from these Git repositories, and maybe you get far with that. But then you come to this other challenge, which is we want something that's more application specific, right? You want something that looks and feels more like an app. And then we think we're asking developers for too much information that we could just generate if we had our own schema. And so then you see a lot of companies building what I call company.yaml, right? Whatever your company name is, .yaml. And that pattern really is, what container do you want? Do you want Prometheus or not? Do you need a database, right? Just the things that you need to know. And from that semantic information, you can generate Helm charts or Kubernetes config. You can generate all these assembly layer-like layers. And so then what happens is that starts to look like your paths. As a developer, I write my code. Maybe I can use a build pack. I don't even have to write a Docker file, but I could if I want to. So you give me that optionality. But then we've evolved so much on day 3 that all I have to do is give you a little bit of metadata, and you just generate all these Kubernetes artifacts that are pretty much what I want to do. And that API will evolve over time. But now you have the early workings of a PaaS. And so when you ask yourself, like, what is a platform then at that point? It's a contract between the developers and the infrastructure. And this is why I think people are still in the mode of building their own PaaS, because right now, to be honest, you kind of have to, if you want to support a real big diversity of workloads. But remember what I said earlier, Kubernetes itself is a workload engine. It has some out-of-the-box workloads, deployments, stateful sets, et cetera. But you can add new workloads and, again, have that metadata you ask from your developers that will translate into that workload API. So I think that is the natural progression that all teams go through.
So, hi, Kelsey. First of all, I highly appreciate that you're here with us. So basically, what I was interested in is what qualifies a good DevOps engineer in your mind? What do you think are the performance metrics, the characteristics, the mindedness of someone?
This is really good because I hate the word DevOps a lot. I mean, a lot. The reason why I hate it is because, like, think about the word champion. To be a champion, you have to actually win. You can't just wake up and say, hey, I'm a champion. Someone will say, what did you win? So I haven't won anything. I'm just like champion. I like the name. So I'm a champion. It's like, nah, you gotta, there has to be more to being a champion. There's championship culture. There's a work ethic. There's doing whatever it takes to make it happen. You just can't walk around saying a champion, and it's okay. Everyone doesn't need to be one. So when I heard the word DevOps for the very first time, I guess I was doing it because in that same financial services company, that's the time I taught myself Java. So I came from a system administrator background. Rack and stack the service, you have VMware, some config management. That's where I stopped. And then one day I remember getting really upset at the log messages from the Java apps, like log4j, so much noise. I'm like, why are we putting stack traces in the log when it's info? I don't need stack trace for info, like you're filling up the log server. And I asked the team, especially those errors in the log, I said, oh, don't worry about those errors. I was like, guys, if you want me to pay attention to the errors, I can't be trying to parse which errors matter and which ones won't. So instead of complaining more, I went to the bookstore and I learned Java. I just said, hey, I'm going to learn Java. I wrote some bicycle, bike shop apps, whatever, OOO. And I said, all right, I'm going to take the code and I'm going to try to reclassify the logs that we should ignore. So I turned it from error to info or to warning. And I submitted the code to the team. The team was like, hey, what are you doing? You're not developer. I said, I know, but I need this fixed because all my systems downstream, they're getting overloaded if you just accept this change. And they merged it. And when they merged it and went out, and then we just watched the whole system on the logging side get better. We didn't have to rotate the logs and compact and compress so often. because we cut down logs by 85%. And so I kept doing this. I started learning business logic and rewriting COBOL and taking my Python skills. And I'm turned into a developer because I needed to. And that's what the opportunity was. The opportunity was once I automated all the other stuff, converted everything into RPM packages. We didn't have containers back then. I said, let me work on the app. Can I make the app better? I added health checks. I added mbeans to JBoss so I can actually do programmatic stuff at runtime. No more complaining. If something needed to be done, I raised my hand and said, I promise to acquire the skills required. I learned Oracle. I learned store procedures. I learned how to make database views to make queries less complex and work with the database team to have a better contract than doing full table scans, bringing down production. I just learned everything. It just didn't matter anymore. One day, I moved my team upstairs to where the DBAs and the developers sat. And my director was not very happy. The team that does ops, we sit on the second floor. Developers sit on the third floor. Your team has not been on the second floor for months. People are starting to ask questions. Why are you upstairs when you belong down here? I was like, guys, we don't do JIRA tickets no more. We just getting stuff done that needs to be done. Now, some stuff requires a JIRA ticket, but 90% of it didn't. So we cut down on the communication and boy, we just up here executing. We're just getting it done. Everybody happy. One day, this director wanted to stop that. He asked that we move downstairs immediately and go back to normal because we were setting the wrong expectation. We were setting an expectation that anybody would learn the skills no matter what it took, security, networking, it just didn't matter anymore. No more HR title business. That was the wrong expectation for everybody else because they were not willing to do that. Some people have been at this company for 20 years. And what I learned is they had 20 years of 1 year experience. They never learned anything after that first year. They just keep doing the same thing over and over. And I was applying pressure. That director goes to a conference. He comes back. He says, Kelsey, I know what you're doing now. I said, what are you talking about? He says, you're doing DevOps. And he went on to call everybody else DevOps, even though they didn't do the work. They didn't have the mindset and they were not interested in the results. But lo and behold, they ran around talking about DevOps all the time. And so that's my problem with the word DevOps. I like the spirit. I like the goal, but DevOps can't claim culture. Culture is what you do. So if you want to be a good DevOps engineer, stop with the lines, stop with the HR business, stop with the job, stop with the devs got to learn Terraform. Why does the dev need to learn Terraform? That's not the job. The job is to get code deployed in the most efficient manner possible. And so maybe, just maybe, your job is to hide Terraform so no one else ever has to write it again. That might be the end goal. So when I think about being DevOps, it's not about no tools. And I'm not one of these people that say technology is easy and people are hard. Forget that. Technology is hard because most of it doesn't work as described. So you got to fight it all the time. But the truth is, all of this stuff is hard. And you really got to step back and say, what am I actually here for? What can I actually do? And if that what I can do list is too short, it's on you, not your manager, not HR, not the promotion process, not your team lead. It's on you to figure out how to get the new skills so you can do a bit more and be more helpful to the team and what the team's trying to do. So that's kind of like my thoughts on what it takes to be a good DevOps engineer. It's actually the same thing that it takes to just be a good person, period.
Kelsey, I will now do the terrible thing and slowly end this talk, because if I don't, the beer will get warm, the sausages will get burned, and then not only the kitchen staff will be very unhappy, but also people will not like me anymore. They won't like me for stopping this anyway. But I do have a parting wish for you and for Nicole and for Anne. And my parting wish, I would like you to get together with Urs Hölzle, your fellow guy, and come over to Germany and tell us what you do at Google to move less electrons, because I firmly believe that moving less electrons will kind of save energy, and saving energy will reduce carbon dioxide footprint and be a faster and good thing altogether. So please say hello to Urs. I once met him at a conference. He certainly will not remember me. Make something up with him. We'll make sure there will be sausage and beer, or if you're vegetarian, we'll give you something even better than sausage, something like Bavarian Knödels or so, and with Google. That would be my wish.
Any opinions, and we'll get to it. So as a minimalist, both physically and digitally, I'll give a good answer to that question when the time comes. Look, thanks for having me. Enjoy the nice social event and the food that you all have. And I'm out of here. Thanks for hanging out with me.